A very good morning, students. Before beginning the topic, let me introduce you that you have done your three chapters. है ना? The first two chapters were totally basics. That is basic principle of chemistry, the structure of atom, and the last one was the classification of elements in period and group. Okay. So now from this class, from this topic, I want to convey to you that we have done our third chapter, which is based on periods, groups, elements. We have studied so many different atoms over there. So from now on, we have some chapters based on third chapter that we would start within a deep intention, okay, with a little bit detail. Like in these elements, there were hydrogen, there was S block element, there was P block element, and there is redox reaction that is also based on this topic. So the third is interconnected with these old chapters, that is chapter number 8, 9, 10. This is 8, 9, 10, and 11 chapter. Okay, that means we have to study all my elements one by one in details. Some chapters are in the same class, some chapters are in your 12th class. For example, D block, F block, these are in your higher classes. Okay, this is all about the inorganic chemistry that we have been studying till now. यानी जो हमारा थर्ड चैप्टर है और ये जो सारे चैप्टर्स हम इंक्लूड कर रहे हैं, this is known to be your inorganic chemistry, है ना? And lastly, the first book of your NCERT exercise, that is your known to be physical chemistry. Excepting these three chapters, all we have the physical chemistry. All right. So this was all I wanted to say. Now talking to the point with the new chapter number 9, that is hydrogen. First of all, how much this chapter contains, how much this chapter is made up of for your exam point of view. This chapter contains at least 4 to 6 marks. Either it is for marking scheme. Another point is the important topic of hydrogen is we have to detailed study and properties of hydrogen. Another one is some reactions, and the last one is compounds made by hydrogen. That means first of all we have to study their properties, their physical, their chemical properties. Another one is how hydrogen is able to make another compound like water, H2O. This is compound of hydrogen. Hydrogen peroxide, H2O2, hydrogen gas, H2. These are all the example of hydrogen. But do not mess up with H and H2. I hope you have been studied this from your 9th class, that my hydrogen is just an atom, just an element, whereas hydrogen is a molecule. So we have to study H over here. That is the main basic property. That is the main basic chapter of hydrogen. Okay. So this is all I wanted to explain to you. These three particular topics are over there. This chapter has been divided. First of all, the physical and chemical properties of hydrogen, reactions, and what are the compounds made by hydrogen. All right. So let's start with our first topic. That means we have to study, we have to understand what is hydrogen actually over in our Earth and what are its physical and chemical properties. Okay, so let's begin. This chapter is very easy, bache, and very short chapter. As you see, the number is only for 4 to 6 marks. We have studied the third chapter also, that was also very short and simple. Same as it is, we have been studying the hydrogen. Now the point here is, first of all, we would start what actually hydrogen means to us. What is hydrogen, I would like to say, contains on our Earth. So let's begin. Hydrogen, first of all, is an atom which is symbol of H. Another point is it is so much reactive. It is the simplest atom in my periodic table, which has the simple electronic configuration of atomic number equals to 1. That you all know, that hydrogen is 1s1. Now, another point is it is very abundant on our Earth as well as on our atmosphere. Now the point is we will start with the electronic configuration of hydrogen and we would study how is it important for us. Okay. Now first of all, as you know very well that the atomic number is 1 and their electronic configuration is 1. So according to this, we have 2 points, alkaline metals and halogen. Okay. Now let's start with alkaline metal. We know very well that our alkaline metal are lithium, sodium, potassium. Halogens are fluorine, chlorine, bromine. Okay. And we know that their electronic configuration is NS1, that is 2s1, 3s1, and many more. Same as it is, these are something which are based on 2p5, 3p5, that is np5. Now the first point I want to convey to you, my hydrogen, it can release one hydrogen so that it would behave like an alkaline metal, that is hydrogen would become H positive and it would release its one electron. Or it can gain an electron to become H negative so that its 1s1 would be completed to 1s2, just as like they do 2p5 to 2p6. They would gain an electron. Okay. So there is a kind of resemblance between alkaline metal as well as, between the properties of hydrogen with alkaline metal and with halogen in the basis of electronic configuration. This is the first point. Not only this, there are so many physical properties of hydrogen which somewhat relates to alkaline metal and somewhat relates to our halogen. Let's see how. The first point, my hydrogen, it can make hydrogen like alkaline metal can make oxides, sulfides, like Na is making Na2O, Na2S, same as it is my hydrogen is making H2O, H2S. This is first physical property which is resembling with alkaline metal. Another point is like halogens, they can be in the form of diatomic, like F2, Cl2, my H would be behaving H2. Okay, this is some property. These are the resemblance why hydrogen is relating with alkaline metal and with halogen. But same as well, there are some exceptions, or I would like to say there are some cases in which hydrogen is not even different with the alkaline metal but also with the halogen. Dobara suno, due to electronic configuration, there are some physical properties which relate of hydrogen with alkaline metal and some properties relate with halogen. On the very other hand, there are some properties of hydrogen which is not which do not resemble with alkaline metal and also do not resemble with halogen. Okay, for example, I'm taking ionization enthalpy. Okay. Now I'm taking, these were the resemblance, now I'm taking exception. The very first point in exception of halogen is the ionization enthalpy. Means the energy to remove an electron from its outer state. The lithium and sodium potassium has very less ionization enthalpy. They would easily remove its one electron. But the hydrogen, if it would remove one electron from it, it would become H positive. And the size of H positive is almost, suppose it is 2 into 10 raised to power minus 3 picometer. The size of H positive is so small that is it is almost to 2 into 10 raised to power minus 3 picometer. Another point is, बच्चे, 1 picometer is equals to 10 raised to power minus 12 meter. You know that very well. In the first chapter we have studied picometer is equal to 10 raised to power minus 12 meter. So it would be become 2 into 10 raised to power minus 3 into 10 raised to power minus 12. That is 2 into 10 raised to power minus 15 meter. Can you imagine how small it would be after releasing of one electron? Its atomic size would be so much small that it is almost impossible for H positive to exist free self. मतलब H positive का size इतना छोटा हो जाएगा कि ये अपना it would not be able, it would not be possible for H positive to exist in free state due to very very small size. तो H positive exist ही नहीं कर पाएगा due to small size only in the free state, क्योंकि हमने अभी स्टडी किया है कि it can combine like HX, where X is halogen like HF, HCl. Okay, not in the free state. Please keep in your mind. So this is kind of exception with alkaline metal. Now we have studied that there are some resemblance, there are some exceptions. So what do? We have placed hydrogen with a unique place. We haven't placed it not only in the alkaline metal and not in the halogen also. We have placed it, we have given it a unique place or a unique nature. Okay, so if I'm going to rub this and show you the position of hydrogen in the periodic table, you will see इन्हीं दो के साथ झगड़ा हो रहा था ना कि इसमें रखे हैं इसमें रखे. We have put hydrogen just as the separate, not in the alkali metal, not in the halogen. That's the reason hydrogen always in the periodic table is taken as separate, not in first group, not in the 17th group. Am I clear, bache? Is my point clear? Hopefully you have gotten my point. Why do I explain this topic so much? Okay, this question could become in your exam within 2 marks, that why hydrogen has been placed in the as the separate position in my periodic table. Okay, and I hope I'm clear with the topic. Now let's move with our next topic, that is isotopes of hydrogen. Let's start. Okay, first of all, anyone would like to describe me what is isotope? Yes, anyone, isotope? With same number of electrons but different number of protons. Like, I would like to say they have the same atomic number but the different mass number. And we have also studied that isotopes is not only up to 1 or 2. Like I'm talking about my hydrogen, it has almost 3 isotopes. Hydrogen has 3 isotopes known to be these 3 are known to be the isotopes of hydrogen. And this is known to be my protium. We have named the isotope. This is known to be deuterium. And the last one is tritium. Protium, deuterium, and tritium. Now, if we go along with the definition, hydrogen here is with the same number of electron or the same atomic number, but their mass number is changing every time, 1, 2, 3. So we have named them that there are 3 different isotopes, 1 hydrogen, 2 hydrogen, and 3 hydrogen, known to be protium, deuterium, and tritium. One more point, as you have known only about 1 hydrogen and there is very less information about 2 hydrogen, 3 hydrogen, it is due to the reason of the abundance. It is due to the reason of abundance. Abundance means the quantity, the amount of hydrogen on our Earth atmosphere. If I'm talking about my 1 hydrogen, 2 hydrogen, and 3 hydrogen, the 1 hydrogen is present on Earth in the form of 99% comparative to these two. This is almost 0.15%, and this exists in the form of 0.00. Okay. Moreover, tritium is our radioactive element. That means it always releases some radiation, so it is very difficult for us to check out to get some information about it. Okay, so we have some compounds of deuterium only, but the formation of compound of tritium is almost negligible. Am I clear? The only reason is the abundance, the quantity, that is protium is something 99%, deuterium almost 0.1%, and tritium is very negligible. Okay, so this was all I wanted to explain about the hydrogen and their isotopes. Clear? Okay, now let's move with our next topic, that is the compounds of hydrogen. Let's move with the topic compounds of hydrogen. Okay, first of all, if I'm talking about hydrogen, its first one is H2, that is dihydrogen. Okay, bache. Not only for this chapter, I'm talking for the complete chemistry, for the complete organic chemistry or inorganic chemistry, whenever you will see, just keep in your mind, bache, that whenever we have dihydrogen or any kind of like we would like to say compound, we have to study first its occurrence, second one its formation, and last one is its properties. And properties are of two types, physical and chemical. Am I clear? I'm talking, if we're studying about any compound like H2, like water, we have to remember these 3 points. First one, what is the occurrence of that compound in our daily life, in our earth, in our ocean, wherever it is present. The formation, how is it formed? What are the reactions which can make our particular compound? And lastly, we have the properties, the physical properties and the chemical properties of that particular compound. All right. So let's begin with H2, that is dihydrogen, and we would study what are the actual, first of all, what is the occurrence of dihydrogen. Okay, so dihydrogen is almost 70% present on our Earth crust. And almost 15% hydrogen is present in the oceans and seas. Okay, so I'm talking that 70% of hydrogen is present over the Earth crust, and almost 15 to 20% hydrogen is present in the ocean seas. Not hydrogen, the H2 gas. All right. So now let's move with the formation of dihydrogen compound, which is very important. There are some important reactions on the basis of which we will study how dihydrogen is formed. Okay, so let's begin. Okay, let's start with the preparation of dihydrogen. First, let's start with the laboratory preparation. That means how can we prepare them in our labs, okay? All right. So I want to just convey to you, okay, that laboratory preparation means we need our hydrogen only in the small amounts. So the very first equation we have for the laboratory preparation is the reaction of metal with any acid. Like you have studied this in your 10th class also in chapter number 3, metals and non-metals. We have studied in this particular chapter that if I'm talking about any kind of metal, like I'm talking zinc plus HCl, zinc is getting reacted with acid, it is converting into zinc chloride plus H2. Okay. Zinc is reacting with any kind of acid and it is converting to zinc chloride plus H2. There is formation of H2 gas. Same as it is if I'm talking about zinc with sulfuric acid, it would be converted into any kind of salt plus H2. We need to get how our hydrogen gas, our dihydrogen gas is prepared. The first example is just react any kind of metal in any acid, either it is sulfuric acid, either it is hydrochloric acid. Second point is we can also make it by reaction of metal with the base. Okay, so these are the two compounds, these are the two proper preparation, how my H2 gas can be prepared. Okay, but this was all we had about my laboratory preparation, that we have to just gather very little information about that dihydrogen. But what's the point if we need them in the higher scale for the preparation or for the making of another compound, like we need dihydrogen in the bulk amount. So for that, we need to make them in the industries, in the factories, which is commercial preparation. Okay, so our second point is commercial preparation. Commercial means making it in the bulk amount, making it for the our benefits. There are so many commercial preparation. The first one is we are electrolyting our water. This means we are providing electricity into the water so that it is breaking down into H2 and O2, and we will get H2 in the so much large amount. I'm again repeating, this topic you will study in 12th class in electrochemistry, but I just want to say that if we are electrolyting our water so that it is converting into H2 gas and oxygen gas, this is our first commercial preparation by water. Okay, same as it is, let's start with another topic, that is brine solution. We can make our hydrogen gas from the brine solution. What is brine solution? Brine solution in chemistry is known to be sodium chloride solution. यानी आपका जो simple salt है जो आप घर में use करते हो, common salt, if you dissolve this into particular quantity of water, this is known to be brine solution. Okay. Like I'm talking, my salt is getting dissolved into water. This is known to be brine solution. BRINE. Same as it is, we have to convert it with the help of electricity, with the help of light, so that they would be broken down into Cl2 plus H2 gas. Plus जो भी हमारा रह जाएगा product, like it would be NaOH. Okay, so this is known to be another preparation of dihydrogen gas. Same as it is, we have some preparations also, some other properties also. Let's see one by one, 2, 3, and then we will wrap up the class by taking your doubts. Okay, let's have 1, 2 more reactions. And the lastly, we have very important from the hydrocarbons. Lastly, we have the third preparation of dihydrogen from hydrocarbons. Okay, hydrocarbon is very new word bache for you, and you will study the same topic in the same class but in the higher chapters. Okay, Hydrocarbon means any compound which is made up of hydrogen and carbon. Suppose this kind of compound, which is only made up of hydrogen and carbon. Okay. So if we start dissolving our hydrocarbon into water, it would give you hydrogen gas. Okay. Now, another point is this particular amount known to be CO plus H2, this is known as water gas. Please keep in your mind that whenever we react our hydrocarbon with water, it would make carbon monoxide plus hydrogen. These two are in the form of gas, and this is known to be water gas. Am I clear? CO plus H2 is known to be water gas. This is a question which could become so that what is known to be water gas and what is the reaction behind this. CO plus H2 is known to be water gas. Another point is this CO plus H2 can be used to prepare bigger hydrocarbon. That is the compounds which contain both carbon and hydrogen. So it is used in the synthesis. So it is also known as syngas. Am I clear? CO plus H2 from hydrocarbon on dissolving it into water, this is known to be water gas. Another point, as it is used for the synthesis of bigger hydrocarbon, so it is also known to be syngas, that is synthesis. Am I clear? Same as it is we have done with hydrocarbon, can we react it with carbon? Definitely yes, and we would get the water gas. So if we have our carbon and reaction if of water, it would give you H2 gas along with the release of carbon monoxide. This is very important point, bache, very important case. So in this way, we have produced our hydrogen gas either in the laboratory form or either in the commercial form. Okay. In the very next class, which we will have in our next week, we will start with the properties of dihydrogen gas. That is its physical properties and their chemical properties.